Okay, Matthew, Chase, Michael, we finished number 8 on page 524. I know, Matthew, you got that far for sure, so we're going to start with number 9 and go from there. If you've already worked that, then just skip past this, all right? We're graphing an exponential, and first of all, you notice there's no number being added or subtracted, so I can put a plus 0 if I want to. So the horizontal asymptote is at 0 because that's what number is here. If it would have been plus 2 or minus 2, then that's where my horizontal asymptote would be. You take the exponent, which is x, you set it equal to 0, and you solve. Well, there's nothing to solve. I mean, x equals 0. So we go ahead and we fill in our table of values. We put 0 in the middle because we took the exponent, set it equal to 0, and solved. And so then we have 1 and 2. Negative 1, negative 2. So go ahead and type this into your calculator, and if you do that correctly, you will get out 1/16 here, you will get out 0.25 here, you will get out 1 here, 4 here, and 16 here. And you can check that with your grapher. You type this into your grapher. Don't forget when you type it in to put parentheses around the 1/4, and then arrow, and then x, okay, when you type this in. All right, let's go ahead and take a look at the graph. Your horizontal asymptote is at 0, so here's my horizontal asymptote going across. My first ordered pair is over 2 up 1/16. Next one's 1 1/4, then 0 1, negative 1 4, and then negative 2 way up here somewhere. So you get the idea. It's the curve that we thought it should be. Comes down, hits here, curves, gets closer and closer to the asymptote but never touches it. Now going to the left and to the right, it continues. So the domain would be all real numbers. Up and down, it does not continue. It doesn't go below this line, so the range would be y is greater than 0 because the graph is above the horizontal asymptote at 0. All right, number 10. Number 10, we do the exact same thing. We have y equals 2 3/5 to the x minus 1 power. Now, first of all, there's no number being added or subtracted here, so I can put plus 0. So my horizontal asymptote would be at 0. Next, I take my exponent, which is x minus 1. I set it equal to 0, and I solve. And that gives me the middle value for my table of values. So 1 goes right in the middle right here. And we go up, 2, 3, and down 0, negative 1. All right, if we put a 3 in, let's see. I'm doing a lot of this in my head. Okay, I'm back, and I went and grabbed my graphing calculator, so now we'll go a little faster. Okay, type this into your, oh, by the way, when you type this into your grapher, it would be y equals 2, then put parentheses, then 3 divided by 5, close your parentheses, then arrow, and then x minus 1 must also go in parentheses because that's your whole exponent. Okay, so if you're not doing that, that's probably why you're missing it. 2 gives you out 1.2. 1 gives you out 2. 0 is 3.3. And negative 1 here gives you out 5.6. 5.6. So very quickly, let's draw our coordinate plane. I'm not trying to be super neat with this. Your horizontal asymptote is at 0. We know it's going to be horizontal. That's why it's called a horizontal asymptote. And there it goes, dotted line right there. There's my horizontal asymptote. And my first point is over 3 and up 0.7. My next one's 2. 1.2. My next one's 1, up 2, then 0, 3.3, and then negative 1 would be 4, 5.6. So it looks like a straight line, but we know it has to curve a little bit. We know that because of the characteristics of an exponential graph. So there we go. Moving on to number 11. Number 11. All right, number 11 is y equals 1/2 to the x power, and then minus 5. Now notice we have a number right here, the minus 5, and so my horizontal asymptote will be at negative 5. And then you take your exponent, which is x, you set it equal to 0, x equals 0, so my middle value is 0. Put that right in the middle, so we go up 1, 2, down negative 1, negative 2. All right, let's put the 2 in, and let me pause real quick and type this into my grapher. Okay, when you type this in, you go to your y equals, it should be parentheses 1 divided by 2, then arrow, and then x, and minus 5. You don't need any parentheses because your exponent is just x, so you can type it in like that. That's totally sufficient. And for 2, you're going to get out negative 4.8. 1 will be a negative 4.5. 0 would be negative 4. Negative 1 is negative 3, and negative 2 is negative 1. So there we go. Alright, and let's see what we got here real quick. Horizontal asymptote is at negative 5. 1, 2, 3, 4, 5. So there's my horizontal asymptote at negative 5 going across. And let's see. 2 would be at negative 4.8. 1 is at negative 4.5. 0 is at negative 4. And let's see here, we'll have a curve there. Negative 1 would be at negative 3. And then negative 2 is at negative 1. So you can see the curve pretty much taking place. There's the graph. Moving on to number 12. Number 12. All right, here's the problem. Okay, notice there's a number at the end being added or subtracted. Right here it's a positive 2. So you have a horizontal asymptote at 2. You take your exponent, which is x, set it equal to 0 and solve, so 0. So your middle value for your table of values will be 0. Go up 1, 2, go down negative 1, negative 2. And let me pause and type this into my grapher. You'd want to type in negative 3, then parentheses 3/4, then close your parentheses, arrow, x, and then minus 2. Do not put parentheses around x minus 2. Okay, the negative 2 is negative 7.3. Negative 1 is negative 6. 0 is negative 5. And you know what? That's incorrect because I typed that into my grapher wrong. So if you've been getting out different values, I'm the one that's wrong. So let's back this up real quick here. All right, negative 2 would give you out a negative 3.3. A negative 1 would give you out a negative 2. 0 would give you out a negative 1. 1 would give you out a negative 0.25. And 2 would give you out a negative, let's see, 0.3125. 0.3125. All right, looks like my horizontal asymptote will be at positive 2. So there we go, positive 2. Positive 2, my first ordered pair would be over 2 and up 0.3. Over 1, negative 0.14. 0 is negative 1. Negative 1 is negative 2. And negative 2 is negative 3.3. So a little bit of a curve taking place. I know it didn't get super close to the asymptote yet, but if you were to continue to look at your table of values, you would see it's getting closer and closer to the asymptote. There's our curve again, just like every single one. All right. Okay, number 13 says graph the function and we're going to do 4 of these. I know it's getting a little old graphing, but let's whip these out very quickly and get this over with. Y equals e to the x plus 5. Now notice there's nothing being added or subtracted, so I can put plus 0. So I have a horizontal asymptote at 0. And then you take the exponent, which is x plus 5, set it equal to 0. And bring the 5 over, becomes the negative 5. So here's your table of values. Negative 5 right in the middle, negative 4, negative 3, negative 6, negative 7. Give me a second to type this in. Now when you type it in, you want to hit your E button, which is the 3rd button from the bottom on the left, second E. And E pops up with an arrow and a parentheses. You type in x plus 5 and then close the parentheses. And if you do all that correctly, you should get out. This is 7.4. Negative 4 is 2.7. Negative 5 is 1. 4 is 0.36. And negative 7 is 0.13. Okay, we have a horizontal asymptote at 0, so there's my horizontal asymptote going through 0, more or less. And then negative 3 is at 7.4. Negative 4 would be at 2.7. Negative 5 is at 1. Negative 6 is like 0.3, and you can see the graph getting closer and closer to the asymptote. Alright, I know I'm not super energetic tonight, guys. I'm really tired, but again, this is not here to be fun. This is here to help you so you can get your review sheet done. Alright, number 14 looks like this. Y equals 0.4 e to the x, and then minus 3. So your horizontal asymptote is at negative 3. You take your exponent, set it equal to 0. So your middle value will be 0. So we go up 2, 1, 2, go down negative 1, negative 2. Give me a second while I type this in. Now you want to type in 0.4, then your E button, and up pops E with an arrow and a parentheses. Type in X, then close the parentheses, and then negative 3. That's exactly what it should look like if you're typing it in correctly. Alright, let's see here. 2 would give you out, let me scroll down on my table of values. 2 would give you negative 0.04, negative, no, that is incorrect. That would be right up here. Sorry about that. Negative 2 would be negative 0.04, and 1 would be negative 1.9, and 0 would be negative 2.6, and negative 1 would be negative 2.8, getting closer and closer to negative 3, and negative 2 is negative 2.9. Okay, horizontal asymptote at negative 3. So there's my dotted horizontal asymptote. And 2 would be at negative 0.04. 1 would be at negative 1.9. 0 at 2.6. And then negative 1 is getting closer. Negative 2 is getting closer, but your points would look like that. And you can pretty much kind of sketch or guess the rest of the graph. Here we go. Alright, moving on to number 15. Number 15. Alright, y equals 4e to the negative 2x. Let's go ahead and type into our calculator first this time. So you would hit y equals, then 4, then hit the E button. When you hit the E button, this pops up, and that pops up, and that pops up. Then you type in negative 2x, and then close the parentheses, okay? Let me go ahead and do that real quick here. Okay, there's nothing being added or subtracted at the end, so your horizontal asymptote would be at 0. Your exponent is negative 2x, that's equal to 0. Divide both sides by negative 2. x equals 0, so 0 goes in the middle of your table of values. Alright, so we go up 1, 2, we go down -1, -2. Alright, let's see. 2 gives us out 0.07, 1 is 0.54, 0 is 4, -1 goes all the way to 29, so we're just going to stop right there. That's pretty sufficient. Alright, your horizontal asymptote is at 0, so there's my horizontal asymptote in red going across the screen. My first ordered pair is over 2 and up 0.07, so right there. 1 is up to 0.54, 0 goes up to 4, and -1 is all the way up here at 29. So really you only get to plot about 3 points, but you can still see pretty much what the graph would look like. It would come down, hit here, curve a little bit, and then run parallel to the horizontal asymptote. Alright, and that's number 15. Alright, last graphing one for this section. Finally, it's been a lot, I know. Y equals -v to the x power, and then plus 3. Let's go ahead and type into your calculator. First of all, you would hit a negative sign, then the E button, so this would pop up with this in a parentheses, put in x, then close the parentheses, and plus 3. That's exactly what your screen should look like. Okay, I've got mine typed in. Notice you're adding 3 at the end, so you have a horizontal asymptote at 3. And then if you take your exponent, set it equal to 0, there's no solving to do. X equals 0, so 0 goes right in the middle of your table of values. So 0 goes in the middle, 0, 1, 2, -1, -2. And let's see, did I type this in already? I believe that I did. Yes, I did. And so, let's see, -2 would give you out a 2.8. A -1 would give you out a 2.6. 0 gives you out a 2. 1 gives you out a 0.28. And 2 has an output of -0.43. -4.3. Alright, very quickly, let's draw our coordinate plane. Finally, we're just about done with these graphs. You have a horizontal asymptote at 3, so 1, 2, 3. There's my dotted line going across, horizontal asymptote. And then my first ordered pair is over 2 and down -4.3. And then -1 goes to, wow, that's really a big change. And then from, let's see, 1 is 0.2. And then 0 is 2, and then -1 is 2.6. Here's -1, and -2 is 2.8. So it really increased. This one really shot up quickly and then leveled out quickly, okay? But it still is going to run parallel to that horizontal asymptote. It's not going to cross it. All right, let's take a look at number 17. 17, 18, 19, and 20, evaluate. Evaluate. So let's have some fun. Here we go. Log base 4 of 64. Remember how to solve these without a calculator, and I will not let you use a calculator in the test for these types here. You admit you don't know the answer, so you set it equal to x. Next, you write it exponentially, so 64 equals 4 to the x. And then you say to yourself, I want to write both sides with the same base. And so 4 times 4 is 16 times 4 is 64. So 64 is the same thing as 4 to the third power. So instead of putting 64, I'm going to put 4 to the third power. And then whenever your bases are the same like this, you can cross off the bases and just set the exponents equal. So 3 equals x. Okay. So whenever the bases match, you can cross them off, and 3 equals x. Let's take a look at number 18. Number 18, log base 2 of 1/8. Okay, you do not know what the answer is, so you set it equal to x. Step 2, you write it exponentially, so 1/8 equals 2 to the x power. And then you want to write both sides so they have the same base. I'm thinking right away, here's an 8, so instead of an 8, I could put 1 over 2 to the third power, because 2 times 2 times 2 is 8. So where the 8 is, I put 2 times 2 times 2. And then bring this 2 up top. And when you bring this 2 up top, the 3 changes to a negative, so now I have 2 to the negative third power equals 2 to the x. Okay, your bases match. Just go ahead and cross them off and set the exponents equal. negative 3 equals x. Negative 3 equals x. All right, let's take a look at number 19. Log base 3, kind of the same problem again. Log base 3 of 1/9. You don't know what it equals, so you set it equal to x. So then we have 1/9 equals 3 to the x. And then see this 9, I can write that 9 as 3 squared. And I want to do that so that they both have a base of 3. And if I bring this 3 up top, the 2 will become negative. So 3 to the negative 2 equals 3 to the x. Now your bases are the same. When they're the same, just cross off the bases and set your exponents equal and solve. All right, let's take a look at number 20. Number 20. All right, this will be an interesting one here. Log base 6 of 1. We do not know the answer, so we set it equal to x. And then we say 1 equals 6 to the x. And now you say, well, Mr. Erhart, there's no way I can write both sides with a base of 6 or a base of 1. You're right. However, let me ask you a question. What would you put in for x to make this an equal statement? In other words, if you put, would you put a 0 in for x? Would you put a 1 in for x? What would you have to put here for x so that 6 to that power equals this over here? Well, I've got an idea. Is this not a true statement? 1 equals 6 to the what power? 0. Remember, anything to the 0 power equals 1. So 1 equals 6 to the 0 power. So what does x have to be? Well, it looks like to me x has to be 0 because 6 to the 0 power equals 1. And you want 6 to some power to equal 1. So x has to equal 0. All right, moving on. All right, next on your review sheet should have been number 25. Expand. All right, so we have log base 3 of 6xy. Now look at this, please. The 6 is being multiplied times the x, and the x is being multiplied times the y. So we have 3 parts that are being multiplied. So what I've taught you to do is you can break this thing up into 3 logarithms. Okay, so log base 3 of 6 plus log base 3 of x plus log base 3 of y. That's called expanding. You made it bigger. Whenever your argument 6xy, whenever your argument is multiplying, you can split it up into a bunch of different logs that are adding. Okay, let's take a look at number 26. Natural log of 7x over 3. Now first of all, notice how we have a top divided by a bottom. Do you see that? 7x divided by 3. So whenever your argument is dividing, you subtract. So natural log of 7x, that's the top part, minus the natural log of 3. So whenever your argument is dividing, you can split it up as long as you subtract the 2 logs. Now you're done with this log, but look at this log over here. Aren't these 2 multiplying right here? 7 and x. So you can split this log up into 2 logs. So natural log of 7 plus natural log of x. Then bring down your minus natural log of 3. So whenever the argument is being multiplied, you can split it up into 2 logarithms as long as you add those logarithms. And I'm not sure why I did 26. You didn't have to do 26, so let's just keep right on going. That was a waste of time. All right, let's take a look at log base 5, or no, log of 5x cubed. So log of 5x cubed. Okay, now we have a 5 times an x. 5 times an x, so I know I can write 2 different logs. So log of 5 plus log of x cubed. Then I taught you something else. Whenever there's an exponent in the argument, like there is right here, x to the 3rd power, you can move that exponent to the front of the log. So 3 logarithm x. Okay? Now it's been a while since we've done that, but we did learn that in class. All right? All right, let's take a look at number 29. Number 29, condense. So now we're going to go backwards. These are harder here. We're going to take these and go backwards. Now the first thing you want to do, if there's any numbers out front, like this 2 here, you want to move them back to the exponent. So now I have natural log of 3 squared minus natural log of 5. Now we all know 3 squared is 9, so I really have the natural log of 9 minus the natural log of 5. Now, when two logarithms are being subtracted like this, you can put them together with one log. When two logarithms, log natural 9, log natural 5, are being subtracted, and aren't these two logarithms being subtracted? Sure they are. Whenever two logarithms are being subtracted, you can write them as one log as long as you divide their arguments. So, one argument is 9, it goes here. The other argument is 5, it goes here. So there we go. Let's try another one, number 31. I'm not trying to set a land speed record of going fast, but you can always, look, you can always slow me down by pausing the video, but you can't speed me up. And so I try to go pretty fast, and you can always pause the video if you need to. Okay, we're going to condense this down, all right? Now, the first thing I would do is I would multiply that 2 through. So 0.5 log of 4 positive 2 log of 6 minus 2 log of 2. So I took the 2, I multiplied it through, the 2 went here, and it also went right there. Okay? Hopefully you see that okay. Now next, before you start trying to put your logarithms together, any numbers that are in front of the log you want to move. For example, see this 0.5 right here? This 0.5, it's now an exponent, so 4 to the 0.5. See this 2 right here? That would be positive log 6 squared. And then you leave the negative sign there. Okay, that's fine. We don't want to change that. But see this 2? We move the 2 as an exponent, so 2 squared. Now, if you'll type into your calculator 4 to the 0.5 power, you'll see that's just 2. And then, of course, 6 squared is 36. And then 2 squared is 4. So there we go. Now, let's condense. Let's put these together. I think I want to go ahead and move on to another page here. All right, now look at your first two logarithms. They are being added, so I can take those two logs and put them together. Whenever two logarithms are being added, you can put them together as long as you multiply their arguments. So 2 times 36 would be 72. Then bring down your other logarithm. And now these two logarithms are being subtracted, so whenever two logarithms are being subtracted, you can put them together as long as you divide their arguments. So 72 divided by 4, and 72 divided by 4 is 18. There we go. And you can list it all the way down to that. All right. Okay, let's take a look. This was number, what was it? Number 31. So now we're looking at number 33. Number 33. All right, number 33, let's solve this equation. 3e to the negative x minus 4 equals 9. This is called an exponential equation because your unknown is in the exponent, and this is number 33. And so we want to get the base, which is e, and the exponent, negative x, all by themselves. The first thing you want to do is get them all by themselves. So we have a 3 to get rid of, and we have a negative 4 to get rid of. Okay, so let's go ahead and get rid of the negative 4 first. Let's add 4 to both sides. So if we add 4 to this side, it cancels out the negative 4. If we add 4 to the right side, we get 13. Now we got to divide both sides by 3. So if we divide the left side by 3, that would cancel out this 3 right here, divided by 3, and that would cancel out. And then over here we divide by 3 also, so 13 to the third power. Now, when you get to this point here, what I've taught you to do is you're going to take the log. Now, what is your base right here? What is the base of your unknown? It's e. So log base e, and then equals, and then log base e. I chose base e because my base right here is e. If this base right here had been a 5, then I would put a 5 here and a 5 here. Okay, but it's not. It's an e, so I'm going to leave that at e. Okay. Now, bring down this whole left side, so e to the negative x. Bring down this whole right side, which would be 13 over 3. And now, remember, when a base of a log matches the base of the argument, everything cancels out except the exponent, so negative x equals. And then don't forget that log base e just means natural log of 13 over, that's what log base e means, natural log. And now divide both sides by -1. There's a -1 in front of the x, so x equals natural log of 13/3 all over -1. Now you can type into your calculator natural log. It's the third button from the bottom on the left side. So very quickly I'm going to type in natural log of 13 divided by 3, natural log of 13/3 equals, and then divided by -1 equals, and you'll get this right here. You'll get -1.466. All right, moving on to number 35. Number 35, okay? This is a logarithmic equation, so 5 times the log of x minus 2 equals 11. Now, whenever you have a logarithm on one side of the equation, like we do here, you want to get the log and its argument. Here's the log. Here's its argument. You want to get them all by themselves, so we've got to get rid of this 5. We don't want that 5 there. So we're going to divide this side by 5, so those cancel out. But we got to divide this side by 5 also, so we're left with log of x minus 2 equals, what would that be? 2.2, I believe. Let's see. 2 1/5, yeah, 2.2. And now, once you've isolated the log, you just want to go ahead and write it exponentially. So what is your base here, even though you can't see it? So 10. So if I write it exponentially, it's x minus 10 equals 10 to the 2.2 power, correct? And now x is not by itself. We have to add 2 to both sides. So x equals 10 to the 2.2 plus 2. So type that whole thing into your calculator and you'll have your answer. 10 to the, let me clear my screen here, 10 to the 2.2 power, and then plus 2. I'm getting out a pretty big number. I'm getting out 160.49. All right. Very good. Moving on to number 37. Number 37. Let's see something here real quick. Make sure I'm doing the right numbers. 37. Okay, then 39 and 43. Okay. All right, number 37. Here we go. All right, number 37. We're going to write a power function, or an exponential function, 2, 8.9, and the other one would be 4, 20. So here we go. The model we're going to use is y equals a b to the x. So here we go. I'm going to take this first order pair here. Where the y is, I'm going to substitute 8.9. And where the b is, or where the x is, I'm going to substitute 2 right there. And then we're going to solve for a. So we're going to divide both sides by b squared. So 8.9 divided by b squared equals a, because we divide this side by b squared also, and those cancel out. So now we know what a equals. Now what we do next is we come up here and we take our other order pair and we substitute it in. So y, I shouldn't use the y. For y I'm going to put 20. So 20 equals, now look what I put for a. You see this a right here? This a? What does a equal? 8.9 over b squared. So where a is, I'm going to put 8.9 over b squared. That's what a equals. And then times b to the x power, so b to the 4th power. So really, we're going to solve this for b now. We're doing pretty well. I mean, if you put this over 1 like this, you can simplify that right side. You can cross cancel. There's 2 b's here. There's 4 b's here. Cross it off, and that leaves you with 2 b's. So 1 times 1 is just 1 in the denominator. 8.9 times b squared would be 8.9 b squared. Now divide both sides by 8.9. You'll get 2.247. So 2.247 equals b squared. And now take the square root of both sides. $1.5. So 1.5 equals b. So we're doing pretty well. Now we go way back over here where a equals all of this. So think about it. If 8.9 over b squared equals a, and I know what b is 1.5, then really I have 8.9 over 1.5 squared. In other words, I just substituted 1.5 in for b right here. And that equals a. Equals a. Well, let's see what we got here. We have 1.5 squared. 8.9 divided by that. And you'll get 3.96. And that equals a. So do you know what b is? Yes, it's right here. Do you know what a is? Yes, it's right here. So write your model. Here's your example. Just write your model. Y equals, where a is, I'm going to put 3.96. And then where b is, I'm going to put 1.5. And then x is x. So there we go. You just wrote an exponential function. Now let's write a power function. And for number 39, they want us to... Again, let's make sure we're doing the right problems. 39, then 43. So we're just about done here. All right, number 39, we're going to write a power function. Your ordered pairs are 2, 3.4. And the other ordered pair would be 6, 7.3. Okay? And your power function is y equals ax to the b. Ax to the b, and so we come over here where the y is, I substitute 3.4, where the x is, I substitute 2 to the b power, and now we're going to get a by itself, so we divide both sides by 2 to the b power, so 3.4 over 2 to the b power equals a, because we divide this side by 2 to the b power, and those will cancel. And we must divide the other side also by 2 to the b power. Okay, a is all by itself. That's good. Now we come up here and take our second ordered pair. And where the y is, I'm going to put 7.3 equals, and then next is a. Well, I'm going to pick this up and put this in for a. So 3.4 over 2 to the b power. And then for x, I'm going to put 6. Then all of that's to the b power. Now we're going to try to solve this thing for b, okay? Well, let's put this over 1. Put that over 1. And then we would have 7.3 equals 3.46 to the b over 2 to the b power. Now what you've learned is when you're multiplying unlike bases that have the same exponent, you divide the bases and keep the exponent. So 6 divided by 2 is 3. So now you would have 7.3 equals 3.4 3 to the b power, because 6 times 2, or 6 divided by 2 is 3. And now we're going to divide both sides by 3.4 to get 3 to the b all by itself. So 7.3 divided by 3.4, 2.15. So 2.15 equals 3 to the b. Now we just did a problem like this a little bit ago. Let me go ahead and clear. Well, you know, I hate to move screens here. We'll just stay right here. Okay, we're going to finish it. I'm going to come up here and finish it right here. Put a little line cutting this off. All right, there we go. Now, you're solving for an unknown that's an exponent. B and the base is 3. So what I would say you need to do is put log base 3 on one side and put log base 3 on the other side. Now the reason I chose 3 because your base here is 3. So that's why we put a 3 over here. So log base 3 of 2.15. And then to the right we have log base 3 of 3 to the b. We just brought this whole side over. Now remember, whenever a base matches a base, everything cancels out except the exponent, so we're left with b, and b equals log base 3 of 2.15. Now remember, we do know how to type that in our calculators. We've learned how to do that. It's a base 3. Your calculator does not do base 3. So you would type in the logarithm of 2.15, close the parentheses, divided by the logarithm of 3, close the parentheses. And you should get 0.6968. So 0.6968 equals B. Now, that's not your answer, but I'm going to circle it because we're getting really close. Now, come up here to A. What does A equal? A equals 3.4 over 2 to the B power. What does B equal? 0.6968. So really, I can take this function right here and I can say 3.4 over 2 to the what power? B, and B equals what? 0.6968 equals A. So we type this whole thing into our calculator. So we now have 3.4 divided by 2 to the 0.6968 power, and that does equal 2.1 actually. So 2.1 equals A, and now you know what A equals, and now you know what B equals. So we can write our model right here. We would have, here's your formula that helps you. You would have Y equals and then A, which is 2.1, and then X, and then B to the B power, so to the 0.6968. So there. What we did there is we wrote a power function just like that by using the information that was given to us. Okay, one more problem and we are good to go. So way to hang in there. And here we go, number 43. All right, we're going to graph this function. So y equals 4 over 1 plus 2e to the negative 3x. Okay, now we studied these pretty in-depthly, and they're long, but first of all, step 1, if you looked at your notes, step 1 says find the two horizontal asymptotes. Well, these are called logistic growth functions. They always have a horizontal asymptote at 0, and then they will also have a horizontal asymptote where this top number is here. Okay, C is what actually the model looks like this. If you want to look at the model, it's y equals C over 1 plus a e to the negative rx. Okay, so C, this number up here, is always going to be your other horizontal asymptote, always. So horizontal asymptotes at 0 and 4. That's the first step. And then I want you to find the middle of the graph, and mathematicians call this the point of maximum growth. This is the formula you use to find the middle of your table of values. It's natural log of A over R, comma, C over 2. Now, let's go ahead and go down and work this out. Natural log of A. Now, A is, look at this, A is the coefficient of E, in this case is 2, so natural log of 2. And don't forget with R, you always change the sign. Always change the sign. So here's negative Rx, so it looks like negative 3 is R, but change the sign, so R is going to be 3. You always do that. C is your top number here, so C over 2 would be 4 over 2. So let's see what we come up with. Natural log of 2 divided by 3. Of course, your calculator does natural log of 3, so natural log of 3 divided by 2 gives you 0.55. So 0.55, and then of course 4 divided by 2 is 2. So very good. We found our middle value. And now let's go ahead and enter our function to the calculator, and then we're going to make a table of value. And don't forget, this is our middle value here, so I'm going to go ahead and draw up my table of values before I type this function into my calculator. And I know right in the middle I'm going to put 0.55 and then 2. Okay, so let me quickly grab my calculator and let's see if we can't type this thing into your calculator. First of all, you'd want to type 4 and then divided by, then start your parentheses right away, because you're going to put this whole thing as the denominator right here, this whole thing. So put a parentheses and then 1 plus 2, then hit your E button, and up pops E with another parentheses, so negative 3x, and then close your parentheses twice. So it'll look like this. If you're a little confused with that, it'll look like this. It'll be y equals 4, then hit divided, so this pops up, and then parentheses 1 plus 2, then hit the E button, and this pops up, and this pops up with the parentheses, and you type in negative 3x, and then close your parentheses twice, like that. Okay? And if you do that correctly, your table of values should be very accurate. All right? Okay, let's continue on. Let's go to okay, hold on one second here, guys. I'm making sure I type this in correctly. 4 divided by okay. This should be point. Boy, I'll tell you what, I'm so sorry about that. You guys are probably like, where's he getting 0.55? This should be 0.23, and I apologize. I hate that when I make mistakes, and one thing with the video, you can't go back and fix it. Just so you know, you cannot do that unless you start the whole video over. So just hold on one second here. Okay, back to this. Sorry about that, guys. Natural log of 2 divided by 3 is 0.23, and then 4 divided by 2 is 2. So this right here should be 0.23. And probably a lot of you were way back here wondering where I got 0.5 from. I hope you kept going and saw that I changed that. But anyways, if you're at 0.3, you would next go to the whole number 1, and then 2, and then 0 and negative 1. So using your table of values, if you've already typed it into your calculator, negative 1 is 0.09 is good enough. 0 is 1.3. 1 is 3.63. And then 2 would be 3.98. Alright, let's quickly grab this. Now don't forget what your asymptotes are. Do you see them? 0 and 4 are your asymptotes, okay? Alright, so let's quickly draw our table. Let's draw our coordinate plane. Don't forget we have asymptotes 0 and 4. So here's one horizontal asymptote right here. And the other one is at 4. So we know the entire graph's going to take place between these two dotted lines. All right. Let's see. 2 is almost to 4. So 1, 2, 3.98. And then 1 would be 3.63. And so maybe a little lower, and then 0.23, which is right here, would be at 2. And then at 0 is 1.3, and then negative 1 is at 0.09, so way down here low. So it looks pretty accurate to the S shape you're supposed to get. And they will. This graph will always stay between the two horizontal asymptotes. Okay, so there we go. I know it's not the best video I've ever done. I know I'm really tired tonight, actually getting a little sick here, and so I know it's not the best, but nonetheless, it's still a help video, so I hope that helps you a little bit with this first page on your review sheet.